In this clip, we will start with exploring the data to pinpoint different sources of variation. We will first look at the intensities for one particular peptide. So the peptide that we will consider is from the UPS protein, so it's differentially spiked in the CPTAC study. We will only look to data from one lab, so we have 3 repeats for every spike in concentration. If we plot the intensities in function of the concentration, we clearly see that as the concentration goes up, the intensity goes up. For the high concentrations, we also see that the variability between the 3 repeats seems to be much larger than for the low concentration. And that can pose problems for the downstream data analysis, where we typically assume that the variation across the repeats, across the different treatments, is the same. This is because intensity measurements and concentrations often have a distribution with a tail to the right and have a kind of a mean variance relationship. If we put the data on a log scale, however, so we have a log scale here and here, we see almost a linear relationship between the concentration on a log scale and the intensity on a log scale, and we see that the repeats have a variability that is almost the same. So after log transformation, intensity measurements from proteomics typically become homoscedastic, the variance becomes the same. Another advantage of a log scale is that the data on a log scale, if we typically look at differences between two conditions, spike-in conditions, for example. And if you look at the differences between two conditions on a log scale, this is nothing else than the log transformed fold change, the log transformed ratio between the two measures that we differ. If we use a log2 transformation, a log2 fold change of 1, so a difference on the log scale of 1, is nothing else than an actual fold change of 2, a doubling. If you have a log2 fold change of 2, we have 4 times higher intensities on average in B than in condition A. So you see that this has a very intuitive interpretation, and we also know that treatments often act on the biology in terms of fold changes. And the log transformation has the advantage that we immediately have an interpretation in something that is biologically relevant and that accommodates for this mean variance relationship.